My name is Daniel Northcott. I'm a systems engineer and I'm the team lead.
My name is Jose Lazares, and I'm an electrical and computer engineer, and I'm the ECE lead.
My name is Jean Katba, and I am the software lead.
Hello, my name is Ali Reza Shariati, and I'm an electrical and computer engineer.
My name is Skylar Stokes, and I am the mechanical lead.
My name is Axel Roman, and I'm a mechanical engineer.
My name is Andrew Rivas, and I am a mechanical engineer.
And we are Team Cat Cannon.
First off, we started with this wooden base at the EDC, which took about a month to fabricate and design. And then after that, after the summer, we put all components, Skylar and Jose put all the components on it. As we came back in the summer, we started working on this aluminum extrusion base. And we went from this wooden base to this, and now what you see is all 4 TVs mounted on the side, and we have wheels and motors inside of this base.
Yeah, so jumping right into the drivetrain of the Cat Cannon here, as a mechanical team, we all jointly had say in the design of the drivetrain, including with our electrical engineering lead, Jose. When we got back to campus for the fall semester, we started immediately transitioning from this wooden base here to the aluminum extrusion base, which is partially hidden behind the TVs and the sheet metal there, but that took a long time to actually fabricate. And the design was pretty simple. It's just a simple sprocket and chain design for skid steering. So motors will reduce power to allow it to turn.
The 4-wheel skid steer base uses cord-safe wheels and has been validated on hardware cords with 0 damage on markings, as well as the bolted frame distributes steering and acceleration loads ensuring safe and predictable maneuvering during live performances.
Hi, okay, so now we're going to talk about the electrical systems inside the Cat Cannon. So right here we have the light PO4, which was already mentioned by the mechanical engineers. To our left-hand side, this is going to be the base design for the entire thing after we add all the components in, but we have our 3 ESCs that control 3 brushless motors. Of course, brushless motors are used to, we have 3 pins to triangulate the positions of the motor, so that we needed these ESCs to be able to move those motors. And down below we also have our power supply that converts our battery into AC waveforms to be able to operate the 4 televisions that you're seeing on the sides of the screens currently. And then down below we have our LiPo batteries, or our LiPo batteries, which operate the flywheels and the motors. Further than that, down below we have a drivetrain circuit to be able to drive the vehicle with our 4 motors that you see down there for the drivetrain. This circuit is for back EMF prevention and then pulse width modulation steering. And then after, we also have our firing mechanism and our operating mechanism circuit, which is right here on the left-hand side, right below me. We use this to be able to operate our drivetrain circuit and to operate our flywheel mechanisms to be able to launch the balls. So once again, it uses serial pulse width modulation. Flipping the switch turns on any firing system that we need here, and then our 2 driving analog sticks will be able to operate this vehicle using skid steering, going left, right, forward, backwards. Further down these videos, you'll be able to see it in action.
What I mostly did was about the LiDARs. So I used the multiplexer thing that we can use it to control 4 LiDARs at the same time, not using so many Arduinos. So I used that, and then I made the code for that to send us the data from the detection of the obstacle we have around the cannon.
So moving on to the firing system, we transitioned from shooting t-shirts into tokenized balls, which will be wrapped with advertisement. This allows people to be able to get the shirts in their sizes, concessions, any other type of digital reward that we want to be able to give out. Due to safety concerns of using CO2, we ended up transitioning to an electronic drive wheel system to be able to shoot the balls.
Alright, so this is our firing system. This is 3 flywheels that go about 5,000 RPMs. And these are just internals for the firing system. And this is our fitting system, which we just decided to show it as is of now, so it can be easier to visualize it.
So general idea, balls all get loaded in from right here. And then as you can see, they drop into this chamber right here, where then the actuator extends up, moves this into the wheels, come in contact, and fire off.
The fitting system also includes a dedicated storage barrel, an internal drop feed mechanism, and power actuator that pushes one ball at a time into the firing chamber. The design minimizes jams and maintains consistent cadence during rapid fire sequences. The barrel angle is fixed for safety and consistency, so range is controlled solely through wheel speed and robot positioning. This simplified the mechanical design while ensuring predictable trajectories suitable for live audience environments.
For the flywheel, we have like different mods on our shooting system, so we want to control it at different speed. For example, right now it's at the max level of speed, right? So when we turn on the switch, it's gonna like gradually increase the speed to the max speed of the flywheel that they can rotate. And we have other mods. We can do like the slowest mode, we can do like the mid one, and then all the flywheels together.
And are these all operated by a single switch, or we have multiple switches?
Actually, we have multiple switches. So one for max, one for mid, one for low, and then one for all.
Hello, my name is Daniel Northcott. I am the team lead for Team Cat Cannon, and today I will be going over the project overview, our scope, and some of the goals and how we aim to achieve these, as well as some of our results. Firstly, the goal of this project is to safely engage fans and the audience during halftime shows of sporting events. Our project will promote fan interaction by launching branded foam balls into the crowd, where recipients can then exchange these balls for merchandise provided by a sponsor, such as keychains, lanyards, and more. Our system overview consists of 4 firing systems, one in each direction, sitting on a robot that is remotely controlled to move seamlessly throughout the court. Our frame is made of aluminum extrusion and covered using 4 televisions, which can be used for more sponsorship and branding. Our fire system consists of 13 balls, each housed in a chamber, which are then launched using drive wheels spinning at about 5,000 RPM. The balls are launched into the crowd, to the top of the spin section, and throughout the arena, allowing for nearly all of the fans to be engaged. Our drive wheels are controlled using motors and ESCs with 3D printed drive wheels. The balls are housed in a 3D printed chamber and then pushed into the breech using a linear actuator, where they're then launched into the crowd. Some pictures showing the idea to the right with the working cannon, along with some drawings going over what we have built in some more detail. Finally, our system has been incredibly successful in meeting our project's requirements and sponsor goals. Our next steps are to get it approved by all the necessary parties, such as risk management, facilities, and operations, to get it inside of a live game. Be on the lookout for us at your next sporting event you attend.